Imagine a number so enigmatic that it made Einstein, Feynman, and Heisenberg lose sleep trying to understand it. It appears discreetly in electromagnetism, hides in quantum mechanics formulas, and somehow helps shape the entire structure of reality. We're talking about the number 1 over 137. Despite seeming simple, it might be the key to something much deeper than any equation has ever managed to reveal. Now think with me. What if the existence of everything we know, from stars to DNA, depended exclusively on this number? It only needs to vary a little, and the universe could become sterile, uninhabitable, or perhaps not even exist at all. Even more impressive. Scientists have discovered that this mysterious constant regulates the fundamental force that keeps matter together. Without its specific precision, atoms wouldn't be able to form. Molecules would have no cohesion, and thus, life as we know it simply wouldn't arise. However, there's something even more intriguing about all this. Unlike other measurements, this number has no unit. It doesn't measure time, distance, or energy. It's a pure number. Precisely for this reason, many physicists believe that if we ever want to communicate with an extraterrestrial civilization, perhaps this constant would be the most universal way to say hello. In this video, we're going to dive into the fascinating mystery of the fine structure constant. We'll explore where it comes from, how it acts in the microscopic world, and what role it might play on cosmic scales. Get ready to discover why this constant might not just be a curious number. In fact, it might be the code that sustains the universe itself. But after all, what makes this number so special? When we talk about numbers that challenge human understanding, few compare to the fine structure constant. Mathematically represented as 1 over 137, as we've already mentioned, it appears silently in electromagnetic and quantum mechanics equations. It functions like a hidden signature in the laws of the universe. Its discovery happened through the hands of Arnold Sommerfeld, while studying the atomic spectra of light emitted by electrons. Since then, it has intrigued generations of physicists. To this day, no one knows for certain why this value has exactly this magnitude. The most fascinating characteristic of this quantity is that it doesn't measure anything. It's not a velocity, nor a distance, nor a charge. We're facing a pure number that emerges from the combination of 3 of nature's great constants. These are the electron charge, Planck's constant, and the speed of light. When combined, these 3 quantities form something without units. It results in an absolute value that's independent of any human measurement system. This unique characteristic already makes it something rare in physics, but the importance of this value goes far beyond mathematical curiosity. In fact, this number has a fundamental role in interactions between charged particles. It's what determines the intensity of the electromagnetic force, one of the 4 fundamental interactions of the universe. Thanks to its presence, electrons orbit around atomic nuclei at a very specific velocity, approximately 1 divided by 137 of the speed of light. This mathematical precision allows for atomic stability and the formation of molecules that compose everything that exists. The moment we observe the spectrum of light emitted by atoms, there it is again. The constant appears as a correction in classical formulas, revealing the subtle touch of quantum mechanics. Even in the most precise experiments ever conducted, this value remains constant. It's as if the universe had defined an invisible ruler, an absolute standard to govern its own laws. It remains a numerical mystery that, to this day, no one has managed to completely decipher. But the implications go far beyond the subatomic world. The fine structure constant, also known as alpha, has consequences that extend from the microscopic to the cosmic. Without this specific calibration, the entire cosmic balance would collapse. Considering that electromagnetic force is present in everything involving light, heat, electricity, and magnetism, any alteration in this value would profoundly change the structure of the universe. This would affect everything from the chemistry that allows life to the physics that governs stars. Alpha's influence manifests in extraordinary ways. For example, it regulates how light interacts with matter, determining the colors emitted by stars and the energy released in chemical reactions. Even the quantum vacuum, which seems empty, is shaped by it. At microscopic scales, this constant controls quantum field fluctuations. However, alpha's effects don't stop at the subatomic world. On large scales, this same constant affects the birth and life cycle of stars. Without its regulatory presence, galaxies could disintegrate before forming planetary systems. This way, alpha connects the extremes of physics, from electron behavior to the formation of cosmic structures. Understanding this constant becomes essential for those seeking to understand fundamental interactions and perhaps even a future theory of everything. But what would happen if alpha had a different value? The results of scientific simulations reveal something impressive. When scientists tested scenarios with small adjustments to alpha's value, the consequences were surprising. If this constant were just 4% larger, stars wouldn't be able to form heavy elements like carbon and oxygen. Without these fundamental elements, the chemistry of life as we know it today wouldn't have a chance. Nuclear reactions inside stars would be weaker, compromising the entire cosmic balance. In other words, the universe would be a sterile place, completely inadequate for habitable planets like Earth. Let's now consider the opposite scenario. If alpha were 4% smaller, the problem wouldn't be the absence of elements. It would be total instability. Atoms would lose their cohesion, and chemical bonds would become almost impossible. Stars would burn too fast, exploding before even forming complex systems. Everything points to how alpha's value needs to be just right. The universe seems calibrated with precision to allow the existence of stable matter. These discoveries raise an uncomfortable question. The universe seems adjusted for life. We thus arrive at the concept of fine-tuning, debated by both physicists and philosophers. Does alpha have this value by chance? Or is there something more? Perhaps multiple universes, with different values for fundamental constants. Or maybe a deeper structure of physics that we don't yet understand. Questions of this magnitude challenge both scientific logic and human imagination. Even without definitive answers, the simple fact that alpha exists forces us to rethink our place in the universe, with a mixture of humility and admiration. Despite understanding how alpha appears in equations, no one knows why it has exactly this value. The universe seems to have chosen to use 1/137 as a secret rule. The best models in physics still don't explain its origin. Even advanced theories, like string theory, still can't derive this number from more basic principles. For this reason, alpha continues to be a loose piece in the puzzle of modern physics. Many physicists see in alpha something that might be the first step toward something even greater. Perhaps toward the much-sought theory of everything. A theory capable of unifying general relativity, which explains the universe on a large scale, with quantum mechanics, which governs the microscopic world. Today, these two areas still function as separate pieces. But alpha has a presence in both. This fact suggests it might be the bridge between these two worlds. The fine structure constant fascinates us because it seems to be everywhere, but continues without explanation. The universe seems to have left a signature that we still can't interpret. With each technological advance, scientists try to measure it with greater precision, but its value remains motionless, silent, yet essential. And we wonder, is there something more hidden behind this number? Or are we just scratching the surface of something much larger? However, some scientific evidence suggests it wasn't always like this. Observations of the cosmic background and models of the primitive universe indicate that shortly after the Big Bang, alpha may have been different. Estimates point to a value close to 1 divided by 127. This data leads us to believe that this constant may have evolved along with the temperature and density of the universe. If confirmed, this discovery opens new questions about how the laws of physics may have shaped themselves over time. Even facing these hypotheses, there's no definitive confirmation that alpha has varied. What we know for certain is that at least since billions of years ago, it has remained the same. This constancy by itself is already something extraordinary. Alpha may represent the equilibrium point that allows the universe to be stable and comprehensible. Perhaps one day we'll unravel its origin. But until then, it continues being a kind of silent language. Something unique that unites matter, light, and space in the same invisible structure. And we reach the end of this journey through alpha's mystery. The fine structure constant is one of the great wonders of modern physics. Simple in appearance, profound in implications. Alpha challenges our understanding of the universe and provokes questions that go far beyond calculations. Are we facing a cosmic coincidence? Or does it represent a clue left by nature itself, indicating something we still can't see? Many scientists believe that if we ever reach the much-dreamed theory of everything, alpha will be right at the center of that discovery. Not as a loose number, but as a link between forces that we currently treat separately. Electromagnetism, gravity, quantum mechanics, everything might be connected by this silent constant. Perhaps it's exactly the thread that stitches together the deepest layers of reality. We then arrive at the inevitable questions. Why does alpha have exactly this value? Why does this value allow life to exist? What would happen if it were different? It might simply be the product of chance, or it might represent the signature of something greater that we don't yet understand. Each of these possibilities carries within itself a universe of thoughts, and each answer, however incomplete it may be, pushes us forward. Now reflect on everything this number represents. Think about how much it connects, explains, reveals, and hides. If you're also fascinated by the mysteries of the universe and want to continue exploring themes like this, subscribe to the channel. Turn on notifications. And remember, knowledge is just the beginning.